Hey everybody, this is Larry. This is day 20 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Search in rotated sorted array 2. Okay. So there are a couple of ways to do this. I think for the first version I did it in ternary. I used ternary search just for fun or something like that. But so just to go over so I think the difference between this problem is that they're duplicate numbers, and and yeah, let's go over the complexity of the one without duplicate numbers. So without duplicate numbers, you could just there are a couple of ways to do it. The way that I think um that I noticed last time, and I did this a while ago. I don't remember when, to be honest, but I do have a recollection of this one for some reason, which is that you compare either the first element or something like that, and then compare to mid, and then just binary search for the other number. That's going to be fine for this one, kind of, maybe not. So, I mean that is still a technique that we can use, but now we have to figure out how to analyze that with respect to um, duplicate numbers, right? And I think, to be honest, I don't think you could do it in faster than linear time, because you can kind of prove it to yourself where now if you have a number that's like a needle in a haystack, like you put this anywhere, right? Like if you just have like one, I don't know, one or something, right? Like there's nothing that tells you which direction to go with respect to the number, right? You could start anywhere, you could do any algorithm, it doesn't really matter. You have to go for every one of them to find the one. And I think from that, I think the best we can do is linear time. That said, we can still use, the binary search idea to make the average case better, even though our worst case would not be good. And also, I think it'll be a good practice to kind of analyze how binary search works, and if you can figure out how to write these functions that integral to binary search, even in cases where it's not out log n or something like that, right? So okay, so let's just say n is equal to length of the nums. So how I do it is I usually structure left and right. So left is 0, right is n minus 1, because I like to make them inclusive. And what that means is that both the left and the right is inside the quote unquote the set that we're searching for. So I do it this way generally, and I just take this divided by 2. This is standard so far. So let's just say we have a function if good. So we might have to make some modification here, but I'm just going to write how I generally write it. I think in this case it's a little bit tricky. So I usually write something like this: good if good, good of mid, and then I go okay, right? So I have this array, say, and let's just look at a unique one for now. And if I have a pointer that's here, where do I want to go? I want to go to the left, right? Because wait, what are we looking for? Oh, the target. Okay, well, so here we look at the 3, and we know that between the beginning and, or maybe the end element, I guess you could do it either way. Maybe it actually makes more sense to do that last element. So here, if it wraps around or not, we see if target is between, if it's bigger than this middle element, and also less than the last element, right? Then we can kind of figure out the in between this way and so forth. And that's the two comparison we have to do, right? Where, okay, like let's say we have this array, and left is to the left, mid is this thing in the middle, and then right is to the right. We check whether target can be inside mid, inside left, so you have left, inside left and mid, or between left and mid maybe, or target can be between mid and right? So that's basically the invariant that we want our loop to hold, which is why it's called loop invariant. And now, okay, let's see, right? Let's say there's a mid, and we'll write the unique version first. If target, if num sub mid is less than or equal to this thing, num sub right, then what happens when we return duplicate? Return true. Whoops. I didn't know we had to return a period like the index or something like that. Okay, so then what happens in this case, right? That means that this is strictly increasing, which is even easier for us. There may be a couple of cases where we have to wrap around, which we'll go over. And then in this case, then we set the left is equal to mid, because we know that mid is between well, let's actually I write it this way, but this should be more accurate because we don't know what happens. I think this should be okay, actually. I think we just have to do an additional check to make sure some other things. But in here, we can move the left to mid because we now know that our search range is between mid and right, right? Anyway, as I said, let's pretend that this is unique for now. So then now we do, if num sub left is in between this, oops, mid, then here we know that the answer is going to be between left and mid, so let's go to left and mid, right? And then there are some wraparound cases which we have to handle. So what are wraparound cases, right? What I mean is that, let's say we have an alternate array where it's something like 1, 2, 3, 4, 5, 6, something like this, say, and we're looking for 5, right? If we're looking for 5, this is 6. 6 is mid, for example. Okay, maybe this is not a good example. Okay, let's say this is 1, right? Well, 5 is not going to be between 1 and 3, obviously, and 5 isn't going to be between 4 and 1 numerically, right? So we have to kind of check the math, which is that in this case, if num sub mid is less than, if num sub mid is less than, or you go to target, and num sub left is less than or you go to target, right? That means that in this case it will be in between here, and in this case we can set the right to mid because we know that it's going to be between these two. And then finally you have the opposite case where if the mid, let's say the mid is now 6 and we're looking for 1. Well, if the middle is greater than target and num sub right is greater than target, then left is equal to mid, right? And then at the very end we return with nums of left is equal to target. Again, we don't handle the unique case yet, so let's give it a quick go. I guess we might as well put in this one, even though we know that we do not handle it yet. And let's put in these two. So now let's find 6, 2, just like more testing stuff. And in theory, if you're doing production code, you would, write code or something like that to generate it more automatically to have order cases. But this may have an infinite loop because we don't really handle off by ones and stuff like that, actually. So not off by one, but it's just that the bounds are always going to be, they don't converge, right? And that's something we have to handle. Yeah, it's going to be time limit exceeded. Yeah, so we have to make sure that this does converge, and a couple of ways. Oh, and also we don't have an else statement. Well, what is else, right? If this is not the case for all of these, which I don't know, can this be possible for me? For an exception or something. Well, I don't know for an exception anymore. let's just print error then. And also let's just, I don't know if this prints if it this may be a weird case because mid is literally 0, but maybe not. So here, as you can see, my loop invariant is true, but it is too true in that it never collapses, right? So let me think about how to handle this. So we said left to mid and then the right to mid, but I think we need a thing so that we are able to, so these are not all the example cases, I don't think. Because basically they don't converge, but yeah, how do we handle duplicate numbers? Because the thing is, let's say we have, as we did before, let's say we have 2, 2, 2, 2, 2, 2, 1, 2, 2, 2, 2, 2, and we're trying to look for 1. If we're here, what happens, right? Well, we know that it's not here, and we also don't do anything here, right? So that means that this thing will print an error. So I think we should, in that case, just do left increment by 1. Maybe that will be enough to fix it. Maybe not. It's a little bit hacky way of learning, but well, it's a hacky way of solving. But maybe it's okay for learning. But that means that there's also another convergence even other than this, right? That means that yeah, like let's say when we look for 2, it might be that it just keeps going, right? So okay, fine. Maybe we add a thing where if num submit is equal to target, we return true. I'm not sure that that's the only case that doesn't. That it once the time limit exceeded, but it's worth trying. And struggling a little bit with this one because of the duplicate case. My answer is true. So so there may be another thing that I'm not handling quite well. Okay. So maybe there is a case that I'm not handling. So, oh, oops. Guess I should have done it one at a time, but this is what happens when you keep on doing stuff at 3 a.m. Okay. Wish there's a cancel button too. Oh yeah, if the thing is not in here, what happens? That is interesting. We could actually walk this through manually, and maybe that'll give us some insight as to our case. I think we're very close, but I'm missing some convergence thing. So 3, we go to 0. So we know that we're gonna go left. Okay, let's go. Right, and then now we go 5, and then it's still gonna be in here. Oh, I see. Because it's just mostly because I'm lazy with respect to this, and it shows, which is that these things, right? I think now that we make them not equal to, we can, yeah, we can solve it that way. Because now if they're equal, then in theory that should be handled better. Maybe not. Okay, well, maybe not. Excuse me. Because I think that is one thing that's a little bit harder to do live on the Leetcode website, is that usually I want a debugger to go through this, and it makes things a little bit easier. But especially for infinite loops, it doesn't even print the stuff, I don't think. So it's going to be a little bit harder to debug, because that is usually how I debug things. and there's an off by 1 here somewhere. Huh. Okay, so it does print actually, so I lied. But so yeah, so as you can see, it is as we expected, which is that these two are not converging because when they're 1 delta away, this is going to give us 0, and then the 0 is so 0 is greater than. So let's see. Yeah, so mid is 0, num submit is 2. Yep. So what does that mean, right? That means that we try to. Is this true? Yeah. Yeah. So this is true, and it keeps on being true. So that's why. That's why it's not converting. Yeah. And actually, what we can do is slightly better because we know, and this is something that I forgot to do. That's my bad. Which is that because we removed the equal case, now we know that left is equal to mid plus 1 because now the mid cannot be true, right? So now in the same way, now we could do this to mid minus 1, and this is mid minus 1 as well. So yeah, sometimes you just have to double check your invariants. And I was technically right, but I wasn't super precise. And I kind of hand waved it, and sometimes you have to step back to make sure that you understand what you're doing. And there you go. Wrong in a lot of cases, though, unfortunately. But how did this happen? I mean, these two are right, and then here it is wrong. Why is this wrong? Well, at least it terminates, which is good. Maybe I got a little bit lazy with. Okay, let me double check my things because I think I just kind of copy and paste this everywhere. Okay, so if it is between the left and the mid, then we don't. It's not gonna be in the mid, so this should be good. If this is between those two, then the right is gonna be mid minus 1. No, that should be good too. So if mid is bigger than total, yeah, no, I mean this is also good, but now I don't know why it is wrong. Well, I think there is one because there's a case now where it converges in a weird way, I think. A lot of debugging for this farm. Need more. I need sleep. Yes, as you can see, the left and the right is has gone. That is the risk of doing something like this in this way. It's because the left can be bigger than right, and that means that it is forced. Oh well. Maybe we could just hack it like this. A little bit better, but still wrong, obviously, because we have missing this thing. Let me think a second about first principles. This gives me way low confidence in general now, obviously. But let's see. I'm trying to find 1. Why is 1 no good? So it tries to go for the 3. What? Oh, this is after it already loops. Let's move this up here for a quick second. So it goes 0 and 5, mid is 2, it is 2, so it tries to go to the, oh, did I have, did I miss, because this is just wrong, because if mid is 2, then in this case it went to the right for some reason. Did I have my recurrence wrong? So if I see. So I think what happens was so mid and the right. Oh no, this should not happen. So it should be the other one. So if the mid is bigger and the, I think I phrased this a little bit wrong, or a lot wrong, because it's just not right. Okay, so what we want, for example, is oh, I think this also has to have an additional condition, which is that and let's see, if the middle is bigger than target and the left is, oh sorry, the middle is smaller than target, so it is this case, for example, in which we're looking for the 2, say, right? Say we're looking for the 2 here, then the mid is bigger than the target and the right is, oh sorry, the mid is, what? This is weird. But there's definitely a missing step here. So if we're looking for the 2, the middle is less than the target. Which is true. And the left is less than, oh no, this is just wrong. But, wait, what? Do I need more cases? Did I just missed it? If the mid is bigger than the target and the right is bigger than the target. I mean, this is clearly not right, right? Or not sufficiently right. We need this to only be true if it wraps around, which means that and num sub mid is greater than num sub right. And in this case, it is num sub mid is less than num sub left, which means that it wraps around. Yeah, okay. I mean, it is more, I don't know if it's more correct, but what number are we looking for? This is why we test them, but we're looking for 1, but it goes to 1, 2, 3, because I think it goes all the way to here, because we're missing some cases, because I'm bad at this. So let's actually add those cases, and it only checks the mid. So else if num sub mid is greater than target and num sub left is greater than target, which is this case I think when we're looking for 2, and num sub left is greater than num sub mid, then we can also do this thing. And then also symmetrically, if num sub mid is less than target and num sub left is less than target, oops, num sub right and num sub mid is less than num sub right, then right is, oh sorry, left is equal to mid plus 1. Okay. Okay, wow, still a case, huh? I don't, So okay, 0 to 5, it goes to 3, 5, which is 4, and it keeps going up, which is clearly not what we should do. So first it starts here, and then we go to the right, which is actually good. We go from 3 to 3, 4, 5 here, and we're looking for 3. I see that because we do equal signs, all it's going to happen to is the else. So we have to check that here, if num sub left is equal to target, return true. Otherwise, we do left increment. Maybe that should be okay. To be honest, this looks okay. But obviously, when you spend half an hour on a problem and you have all these conditions, and I don't even think I did that well, it's going to be a little bit hard to be confident about it. But let's go. Mostly because it's 3:30 a.m. and I'm tired. Wouldn't be surprised if I got a... Okay, well, this is just a silly wrong answer, I suppose. But... because that's not even really... And also, if you watch me for my last couple of weeks, I always test the zero case, but I think today I got a little bit tired from this problem, and then I don't test it, and then that checks it. So, yeah, well, some days it's a little bit sad. Okay, but there's an actual wrong answer, which is fine. I mean, sad, but fine. So 5 is clearly in this. We know that. I just wanted to put in the test case. Let's bring back the debugging. So 0 and 2, it goes to the 1, 5, 1, so it's going to increment all the way through. It should go here, right? Here. Because 5 should not, like, none of this should trigger because the target is 5. So, no, it doesn't. What? I think one of these triggered by accident or unintentionally so, because the 5 is bigger than both these numbers, so target is bigger than the mid and the left and the so it's going to be something here, and the right is bigger than the mid. I think one of these signs is just wrong, or maybe I'm just really wrong. Give me a second to recollect myself. My apologies. It's just that if this was a contest or an interview, you have to step back and just make sure your assumptions are right around the intuition, and clearly it's something that's really off here. I should do it as another one, but okay. So the target is bigger than those cases, but this does not wrap around. So our condition for calling it a wraparound is wrong. So that's the problem. It is a wrapper. This is not defining a wraparound, obviously. I think this has to be here in both cases. It's just that I was a little bit weird about how I defined it. And also some of it is that I wrote this in a weird way or inconsistent with the other one. And that's why when you talk about readability and symmetry, that's what happens, right? I was looking for that symmetry and that's what happened. That was a very subtle mistake actually, but that's why when you look at, when you write consistent code that is symmetric, and that's why people talk about that, you're able to spot those bugs a little bit easier. Hopefully that is worthwhile for me to stumble across to them. Let's try again. Come on. Yes. Whew. Not sure what I was going to do if that wasn't it. That was a good trick to capture typo actually. But okay. Cool. So what do I have here? I mean, so the worst case, this is going to be linear time as we talk about because of like this case. On average, it's going to be log n if they're not that many, or in the best case maybe. Well, best average case will be log n when there are no duplicate numbers. In terms of space, obviously we only use constant amount of variables, so it's going to be all 1. Yeah, let me know what you think. It's a very annoying problem, very tricky. Maybe you did it better because I didn't do it that quickly. It took in half an hour or so with a lot of mistakes and just typos and incorrect assumptions. But that's part of the learning process. I hope you learned here with me, and I will see y'all tomorrow. Bye bye.